Good afternoon all. So in the last class we have seen artificial neural network and fuzzy logic system introduction, what are the contents in different units and how the coming sessions are going to be. So that's what we have seen, and the objectives of the course, outcomes of the course, and what are the textbooks and reference books. Those things we have seen in the last class. In today's session we'll see what are the fundamentals of neural networks. So fundamentals of neural networks, like how neural networks have been evolved and what is the motive to derive or to develop these neural networks. Those things we'll see in this session. The fundamentals of neural networks, like it is a simplified models of biological neuron system. So biological neuron system means our brain. Human brain is called biological neuron system. So it is a simplified model of biological neuron system, and it is massively parallel distributed processing system. So parallel distributed means communication will be faster. So that's why it is massively parallel distributed processing system. Even computers, we are thinking that computers are faster. Computers are connected in series parallel processing system. There we use sometimes series and few parallel, but human brain is massively parallel distributed processing system. That means you can feed the data fast and you can retrieve the data also fast by using the human brain. So that is a feature of that human brain, and it is highly interconnected neural computing elements. So neural computing elements here in human brains generally we call them as neurons. So the similar way human brain, part of the human brain, small portion of the human brain, if you are mimic that small portion of the human brain, that becomes the artificial neural network. So another thing is, so this neural network has an ability to learn and acquire knowledge. So ability to learn and acquire knowledge means if you are teaching it properly, if you are training it properly, neural networks can acquire the knowledge, and based on that knowledge, what are the inputs, and based on the training, it will give the output. So here training is very important. It is nothing but neural network learning. So that learning methods are there. So different learning methods, by using different learning methods, will get the different outputs, required outputs. So here neural network architectures are classified based on the learning mechanisms and other features, like by what learning mechanism you are using or you are feeding it to the neural network. Based on that, the neural network function will decide. If you want to get more accurate neural network, you have to train the neural network, or neural network have to learn the more data. Then only you can get the output. So based on that learning mechanism, these neural network architectures are going to be classified, like supervised learning, unsupervised learning. So these are the different learning mechanisms in the neural networks, and these are the imitations of central nervous system and also motivated by the human brain. So this neural network have come into the picture because of the human brain. So if you are mimic the part of human brain, then we have achieved the neural network. So that's the motive of the neural network evolution. So it is imitating the central nervous system in the human brain. So like it's a similar function. Artificially we are doing it. That's why it is called artificial neural network. So next, the structural constituents of human brain termed as neurons, and these are called the entities of this neural network. So generally in human brain we are having nerves or neurons. Those are the entities of this structural constituents, and it performs the following computations. That means neural networks, what are the functions of the neural networks means it can give the cognition, logical inference, pattern recognition, and so on. So cognition means generally if you want to learn something or know something, so it should have some ability to learn. It should take some inference from the data. So that logical inference should be there to the neural network. So it has that capability in pattern recognition. So generally if you see the person 10 years back, we are able to recollect that person's image. When that person comes in front of us, we would like to recollect the entire data. That is his name, his appearance, his memories, associated memories with respect to him during that time. So all those things will come into our mind, even though that was happened 10 years back, long time. So because the nerves are, as this is massively parallel distributed system, so it can fastly recollect the data just by seeing the person. If person comes in front of you, all the data comes into your mind and you can speak directly with him. So without any delay. So this is not possible for the computers, because computers, we have to train the computers. If you are training the computer or if you are training the robot, during that time if you are feeding the data last 2 years, means that can recognize or that can recollect the last 2 years data only. So it cannot go beyond that. But human brain is not like that. So once from our childhood, from our birth onwards, so whatever the things are there that we are able to recollect, sometimes we may fail to recollect also, because if neurons are not interconnected with one another, if those neurons are not activated with one another and it is not connected to that particular memory, then we fails to recollect that data. So these are just like electrical pulses. So these electrical pulses have to be activated by using these neurons. One neuron is connected to the another neuron, and likewise parallel connections will be there. Our human brain is having around millions of neurons, billions of neurons. So these million or billions of neurons have trillions of interconnections. Trillions of interconnections means it has more number of interconnections, parallel interconnections. Even we cannot imagine that parallel connections also. One can be, for example, we can see the parallel system. All nodes are connected in parallel, means simply one is connected to the two. If two nodes are there, means one is connected to the node. That is simple thing. But such neurons or such in the biological neuron system, such parallel connections are in terms of in the number of trillions. So imagine, so what in all possible ways it is trying to connect with the memory. It is able to recollect. So this pattern recognition, that is what it will happen. Generally, you might have seen your mobiles also. Mobiles generally you will if you take the new mobile, we have to give our for face recognition mobiles. In the starting, we have to show our face. So this is my face. So if next time if you see this kind of face, so lock should be open. The training we have done earlier. That's why whenever we have shown our face in front of the mobile, that mobile will be unlocked. It's face recognition or pattern recognition. Pattern recognition, simply if you want to go for some lock unlock system by using some pattern, by using your numbers. So initially you have to train that system or phone. Then only next time it can remember that thing. So that's what we are going to do. All these things have come because of this neural networks. So next point is imitation of computing by human brain, termed as artificial neural system or artificial neural network or neural networks. So all these are same terminology. So artificial neural system or artificial neural network or neural network. So these are the different terminologies for the neural networks. So coming to the definition of neural networks, according to the DAPRA neural network study, so the simple definition, a neural network is a system composed of many simple processing elements operating in parallel, whose function is determined by network structure, connection strength, and the processing performed at computing elements or nodes. So this is a simple definition given by DAPRA. So what he is saying is neural network is a system composed of many simple processing elements. So like I told you, all these elements are connected to massively parallel and distributed network system. So those network systems or these connections are depends on the connection strengths, whether it is weak connection or whether it is strong connection. If it is weak connection means we may not able to recollect the data. Sometimes if you are failing to recollect the data means from one neuron to other neuron, from one node to other node. So we are having weak connections. So the weak connections are not able to connect with the other neurons, even though it is connected in parallel, or that is not having sufficient strength. So that's why we fail to recollect the data. So this is one of the definition, and another definition is according to the Hawkins, a neural network is a massively parallel distributed processor that has a natural propensity for storing experiential knowledge and making it available for use. It resembles the brain in two respects. One is knowledge is acquired by the network through a learning process. Interneuron connection, second one is interneuron connection strengths known as synaptic weights are used to store the knowledge. More or less all the definitions are same, but in more lighter way or in more other way to understand it more clear. So this is another definition. So here also same thing. Neural network is massively parallel distributed processor. So it has some ability to store the data, whatever it is experienced. Experiential knowledge means whatever it is experienced by learning or by remembering or by feeding some data, it has some experience. Then it will be available for the use whenever it is required. So it it resembles the brain in two respects. Means one is knowledge is acquired by the network through a learning process. Means, so if you are learning something, if you are training the neural network in some respect, in some way. So if you are learning, or if you are teaching, or if you are feeding the more data, it is able to recollect the more data. And the second one is interneuron connection strengths known as the synaptic weights. Even whenever we go for the artificial neural network model, there we'll see. So it is synaptic weights, those things. So generally the synaptic weights will decide how much strength the neural network connections have for interconnecting between one node to another node, or between one neuron to other neuron. So it depends on that, the knowledge or that information also stores from or exchange from one neuron to another neuron. So next one is the physical structure of the human brain. So this is a cross-sectional view of the human brain. So here if you see, this is a cross-sectional view, and here I have given only from the textbook. I have copied this figure, and the key terms of this human brain are human brain stem, spinal cord, and cerebellum. So these are the key parts of the human brain. But if we see specifically the structure of the neuron, if you understand the structure of the neuron, you can understand the artificial neural network, because the artificial neural network have been developed based on this biological neuron structure. So what you are seeing here is biological neuron. So in the biological neuron, you see this axon is connected to the cell body, so which is also called as soma, and other parts of the neuron are like synapse and dendroid. So here dendroids, synapses, cell body or soma, and axon. Here axons are like a transmission lines. So to transmit the data from one neuron to other neuron, or one cell body to other cell body. So it functions like transmission lines. Okay. Then dendrites are used as a, here let's see this, the dendrites are act like a input source. We call that as basal dendrites, so which are used to receive the input information. The third point. So dendrites are used to receive the input information, whereas the synapses here, synapses or synaptic terminals, those are act like a output terminals to make the connections with other neurons. You see, other neuron connections also have to be go from the synaptic terminals. Here synapse is there, right? So the synapse is used to connect, or it is the interconnection of one neuron to other neuron, or one cell body to other cell body. So here dendrites will receive the information, and synapses will send the information through the axons to the other neurons. So the axons act like a transmission lines to carry the electrical signals with high resistance and capacitance. So these are the functioning of human brain. The same we will mimic in the artificial neural network. So generally it is a small comparison between the human brain and computer. Generally brain computation. Here the human brain contains about 10 billion nerve cells, billions of nerve cells or neurons. So with 60 trillions of interconnections, we are having billions of neurons and trillions of interconnections. Interconnection means parallel, massively parallel distributed means based on the interconnections only that name have come. Because of that only, faster the information is able to recollect in a faster way. On average, each neuron is connected to other neurons through approximately 10,000 synapses or synaptic terminals. So here already we have seen that what is synapses and or synaptic terminals. On average, each neuron is connected to the other neurons. So one neuron is connected to the other neuron through the synapse. But with how many synapses it is going to connect means it is going to connect around 10,000 synapses or synaptic terminals. You see here, this is called synapse. So likewise, one neuron is going to connect through an average of 10,000 synapses with other neurons. So what we have seen in that just one part of the neuron only we have seen, but it is a massively parallel distributed network. So if you see here, the first row is human brain, second row is man-made computer or machine. So if you see the processing elements, so here we are having processing elements in the human brain. Those are called synapses. 10 power 14 synapses are there as a processing elements. In computer, 10 power 18 transistors. Generally we are termed as transistors. By using the transistors only, the processing elements have designed. So 10 power 18 transistors are there for one particular processing unit. So element size, energy usage are almost same for human brain and computer. But the processing speed, if you see, so even though that is mentioned in terms of speed, here it is given in terms of hertz. So if you convert that into the speed, which is having less frequency, will have more time, right? So if you see 100 Hz processing speed means 1 by 100 Hz, whereas computer 1 by 10 power 9, that is equal to 10 power minus 9 seconds, whereas human brain 10 power minus 2 seconds, which is much faster than the computer. And the computation of the human brain is highly parallel and distributed, whereas computer is computing in serial and centralized way. Next point is the fault tolerant in computer is that means the computer cannot go for fault tolerance, whereas human brain can. If any fault occurs, it can able to detect the fault and it can able to it can tolerate means again it can rectify the by within brain itself. But whereas in computer it requires again additional functions or additional assistance is required to rectify that fault. So it is not auto fault tolerant. Computers are not auto fault tolerant, whereas human brains are auto fault tolerant. It can automatically detect the fault. If some fault occurs, again it can rectify that fault also. So there is a fault tolerant, and computer is able to learn the new things. But whereas human brain is going to human brain is able to learn the new things. The brain is having that capability, but computer is also able to learn the new things, but it requires proper training. And if you compare with the human brain, it is a little slower in terms of learning. So last point is intelligent or conscious. Intelligent and conscious. Generally, intelligent and conscious is usually human brains have that intelligent and consciousness, but computers doesn't have that intelligent and consciousness. You might have seen that Robo movie also. So in that movie also, what finally the robots have built with some sensation as well as some intelligence, some consciousness. But such robots or such machines have not completely come into the market. It requires more research and more yet to come. But whereas human brain has that intelligent and consciousness, unlike the computers or machines. So this is all about the brain computation and the comparison between the human brain and man-made machine or computers. So these are the interconnections in brain. Like I have shown you earlier, one neuron model. So here, structure of the neuron. This is one structure of the neuron. But such type of neurons, many connections will be there. Trillions of connections will be there in the human brain. Like this. And this is a biological neuron, what we were seen earlier. So with more parts like biological neuron or motor neuron. Here dendroids, basal dendroids are considering as input zone, or it receives the information through axon. The information is transmitted. It's why the axons are used as a transmission lines. And it will connect to the synapses or synaptic terminals. The output zone terminals are called the axon endings, which are termed as the synaptic terminals. Output zone or axon endings are called the synaptic terminals. So one cell body to other cell body through its output zone or synaptic terminals only has to be connected to the other cell bodies. Again, other cell bodies also have the similar type of structures. So like we were discussed, around 10,000 of synaptic terminals are there to connect one cell body with the other cell bodies. This is all about the what we were seeing. Thank you.